Hey guys, so in today's video, I know it's been a little while, I had like two tests, but anyway, so in today's video, I want to talk about a one proportion Z interval to kind of just finish off what we did in the last video, and then I'm probably going to pivot to something else, but regardless, let's do this. So, what is a confidence interval? So let's say we have a sample, right? And it's like p hat equals zero point 0.5, right? So let's say that, well, let's just say like 0.51 for this. So let's say, like, I don't know, we're picking from 50 frogs and we get that this many are male. So like 51% of them are male. Like just in our sample, which, well, that's not possible in this case. So let me just say 52%. So like 26 out of uh 50 frogs are male is what we counted. And we want to know, well, realistically, what's a good estimate of the population proportion, right? So, like, out of all the frogs in the world, not just our sample, what do we estimate the proportion are that are male, right? How many are male? The proportion. So, to do this, we need conditions first. So, conditions are going to be basically the same as other one. So, we have one that p hat is from a random sample. Right? Simple random sample. You probably shouldn't abbreviate that, but I'm going to. And then n is less than 0.1 n. So our sample size is less than 10% of the whole population. So in this case, you would say like 50 frogs is less than 10% of all frogs. And you have to write it like that. You can't write it like this. I'm just like kind of making it shorter for notes' sake. Then two. So you might remember in the last video, we had n times p and n times p minus 1. But here we don't have a p. We're trying to look for it. So instead, we're going to do p hat. So we have n times p hat and n times, I'm sorry, this is supposed to be 1 minus p hat. So in this case, let's just use this, right? We already said that 50 times 0.52 is 26. Because that's how many of our frogs were male. So doing n times 1 minus p, what do we get? Well, it's just 50 minus 26, so 24. And both these are greater than 10. So otherwise, the wording of the thing is the same. So we say by, well, let me just type this out. By the CLT, we can assume the sampling distribution of P is approximately normal. Now, you see, I didn't write, I want to write this in just because I can't really do that, but you say p hat, right? The sampling distribution of p hat is approximately normal. So three, we have to say the name of our test, which in this case is not a one proportion z test, but it's a one proportion z interval. It's an interval, right? Not a test. But otherwise, the wording is exactly the same. So for p, we get this. We can say the same thing as last test, right? So the true proportion of frogs that are male. All frogs that are male. So P, remember, just the population proportion. So the true portion of all the frogs in the world or wherever we're looking that are male. So we have our conditions now. And now we need to go to testing. So let's say that it's asking for a 95% confidence interval. Now, the percent, so 95% just means that every time we calculate an interval, so like with a different sample, 95% of those intervals will contain the like population value. Um, and so that means that 5% won't, but 95% is a good number. I mean, and the questions, a lot of the questions have different numbers. I'm just using this for now. So we're looking at our testing, and we don't have any hypotheses here, so we don't have to write any of those. But we do have to write what we know. So we know that p hat equals 0.52, and that n equals 50. But what's one thing that we don't know? Well, confidence interval, we need z. So for the test, right, the test you have to find z, but for the confidence interval, you know z, you have to find like the interval. So this is going to be different for each like percent, but for 95%, it's just 1.96. And you can find this on a formula sheet, right? Or you can look up like normal distribution confidence interval z values or something. Right? This is just like how many standard deviations away from the mean leaves us with like 0.025% on each side. Because if you double this, then and you add it with the what's in the center, right, which is our 95%, then we would get 100%, right? So that's how much is on each side, 0.025. So z equals 1.96. Now to calculate the interval, we're going to take our p hat, so our estimated population value, right? Let's just say that's what p hat is, plus or minus our z times the square root of p hat times 1 minus p hat, which is 0.48, over 50. And this is the standard error. Which you can also find on your formula sheet pretty easily, or you can just look it up, right, if you're not doing this with AP Stats. So let's calculate what this is. Just give me a second. So using the calculator, and I'll explain how to get there, I get 0.3815, comma 0.6585. So to get there, you're gonna want to do stat, like press stat on your calculator, go to tests, and then scroll down to A, test A, which is 1 prop z in. Anyways, it'll give you an interval like this. And basically what we're saying is we are 95% confident that the true value of p is between these two values. So that's basically just our conclusion. So let me write this in a generic way first. We are X% confident that the true proportion of whatever is between blank and blank. So our X% here is 95%, and that depends on what width the interval is. So like if the problem says calculate a 98% confidence interval, then this would be 98%. And the true proportion of whatever is just what we define here. So for us, that would be the true proportion of all frogs that are male. And then it's between blank and blank. That's just the lower bound and the upper bound of our confidence interval. So for us, we are 95% confident that the true proportion of of all frogs that are male is between 0.3815 and 0.6585. So essentially, if we took multiple samples and we did a confidence interval for each sample, 95% of them would contain the actual p-value. And in this interval, well, we're just saying that we know that we're 95% confident that it's between these two values. Now, that doesn't mean that it's a 95% chance. Okay, it kind of just is like an alertness of like how specific our interval is, but it doesn't mean it's a 95% chance because it's either in the interval or it's not. So don't get that confused, right? Just remember, like, if you see a multiple choice question or something like that, it's going to say in 95% of confidence intervals that we do, like using the same sample size, we would get the p-value, right? Or the p-value would be in it. And that's really all I have for you guys today. Kind of a shorter video than last time, but it's also, intervals are kind of shorter. So, thank you guys.